Hi class! In this lecture video, I will be discussing parallel circuits, but a review of a series circuits first. We learned in the previous discussion that a series circuit contains more than one circuit component connected one after another in a single path. So there is a single path for current to flow. The current flowing in the single path produces the same or has the same magnitude in all parts of the circuit. So current is constant in all circuit components in the circuit. However, though, the disadvantage is that if the circuit is broken at any point or a certain circuit element is broken, no current will flow. So the current will cease. That is why it is quite disadvantageous for home appliances to be connected in series. In the contrary to that, parallel circuit is a circuit in which two or more electrical components that are connected across each other. Across each other. Which means in such a way that the current is distributed between them. So current is distributed. What do we mean by that? The magnitude of current in each of the circuit elements in a parallel circuit is not the same. However, though, the voltage drop across each of the circuit elements would be the same because, again, there is an alternative path for current to flow. And these circuit components seem to be connected to the battery. So the battery is connected to one of the resistors directly and another, and then the last circuit component. So these alternative paths provide or is the reason why the voltage drop across each of the circuit components connected in parallel would be the same. Now, you should note as well that in a series circuit, the more resistors that you add, the higher or the more that the equivalent resistance increases. However, in a parallel circuit, connecting additional resistors in parallel decreases the equivalent resistance. As you can see from the formula here, it's an addition, yet it's a fraction in fraction form. So the more that you add resistors in a parallel circuit, the lesser is the equivalent resistance. So there is a decline in resistance, equivalent resistance, as you add more resistors. Okay, and voltage is, as mentioned earlier, constant. Let's take, for example, a certain parallel circuit with a voltage source of 9 volts, or the electric potential of the circuit is 9 volts. And let's say there are 3 circuit elements, say a resistor, that are connected in this parallel circuit. Second, the third, and the fourth. So let's label them R sub 1, R sub 2, and R sub 3. Now, let's assume that R sub 1 is equal to 1 or 2 ohms, just like in the previous problem. Let's say R sub 2 is 1 ohm, and R sub 3 is 3 ohms. There. Now, here are some points to remember in a parallel circuit. Number one, the voltage across, voltage drop across each element is constant or the same. What do we mean by that? If you'll notice in the circuit, there are some points which we call as junctions. Junctions are important in a circuit because it allows or provides an alternative for current to flow. What are these junctions? For example, in the circuit, we have this particular point, which is our junction 1, another one right here, here, and here. Notice at these points, once current starts to flow from the battery, upon reaching the, the junction will provide an alternative path for current to flow to resistor 1, as well as an alternative path for current to flow to resistor 2. Likewise, upon reaching the second junction, current will be flowing also to the third. At the same time, it flows to the second resistor. This allows the voltage to be constant across each of the circuit elements. It appears that all of the resistors connected in parallel are directly connected to the battery. Now, this tells us that the voltage total is also the value of the voltage drop across the first resistor. That is also the voltage across the second resistor and in the third. All right, so from this we could say that the V sub 1 and V sub 2 and V sub 3 are all equal to 9 volts. Second point to remember. The second point to remember is that in a parallel circuit, as you increase, as the resistors, as resistors are added, the equivalent resistance decreases. What is the meaning of that? Because in a parallel circuit, the formula for equivalent resistance is 1 over R sub EQ, or equivalent resistance, is equal to the ratio, the fractions of 1 over the resistance 1 plus 1 over resistance 2 plus 1 over resistance 3, and so on and so forth. If you'll notice that these are all in fraction form, and when you add them, the greater is the denominator, the lesser is the value of the fraction. So the more you add the resistors in a parallel circuit, the lesser or the more that the total resistance decreases. So in this particular example, if you'll notice, if you want to compute for the equivalent resistance, you simply consider the fraction forms of those resistance values. So 1 over 2 ohms for the first resistor, 1 over 1 ohms for the second resistor, and 1 over 3 ohms for the third. So if you add the values up, you pause the video if you want to solve. Get 11 over 6. ohms. Now remember, this is not the equivalent resistance. This is 1 over equivalent resistance. So to get the exact value, you get the reciprocal of this fraction, and that is Req over 1. So you just have to reciprocate the answer, and that is 6 over 11 ohms, or in fraction, that is, or in standard form, that is 0.54 ohms. So what do you notice with the value of the equivalent resistance? It is only 54.54 ohms, and this is lesser than any of the given resistances. Okay? Because as you add more resistors into a parallel circuit, the more that the total resistance decreases. And what does it tell us with current? As you increase the resistors in a parallel circuit, the total resistance decreases. Therefore, the current flowing in the parallel circuit increases. That leads us back to the formula V is equal to IR, where I, or current, is inversely proportional to resistance. So in a parallel circuit, the more you increase the resistance, the more you add resistors, the lesser the resistance value or equivalent resistance value gets. So the total current in the circuit increases. So it's really efficient to connect devices in parallel, because the more you add more loads, the lesser is the resistance and the greater is the current. Now, what about current in a parallel circuit? The current in a parallel circuit is distributed, which means that the current is dependent on the values of the resistance. Meaning to say, if you want to compute for the current in resistor 1, we must consider the resistance value at that particular circuit element. Using Ohm's law, I is equal to V over R, where V here is the voltage across that resistor and the resistance of that resistor. Now take note that the voltage is constant across a parallel circuit, so we will input the same value, the value of the battery source. So 9 volts divided by the first resistor, 2 ohms. If we want to compute for the next, I sub 2, we do the same. V sub 2 over R sub 2. So again, 9 volts over 1 ohms. And I sub 3 is V sub 3 over R sub 3. So 9 volts again, all over 3 ohms. You may pause the video if you want to solve. You're done solving. The answer for the current in resistor 1 is 4.5 amperes. For the second, we have 9 amperes. And for the third, we have 3 amperes. So these are the values of the current in the whole circuit. So to verify this answer, we could actually use the values that we calculated for the equivalent resistance as well as the total voltage. To do that, you can just simply use Ohm's law. V is equal to IR, where V is the total voltage and R is the equivalent resistance. So if we want to verify our answer, if they are all correct, the total current is equal to the total voltage divided by the R equivalence. So the total voltage is 9 volts divided by the equivalent resistance we calculated a while ago, which is 0.54, we would get 16.6 amperes. Notice that if we add these resistance values, current values, we'd actually get approx 16.5 amperes. And that tells us that our current value, the calculated value for current, is correct. Okay? So they are approximately equal with each other. And that is how you check your answers. That is all for parallel circuits. Thank you for listening.